Hello everybody, on today's activity, we were asked to make a video presentation about the Leap 4. The topics will include Law of Reflection, Malus Law, Shell's Law and the Index of Reflection, Total Internal Reflection, Polarization, and Dispersion. Hi, my name is Giona Kyla David, and for today, I will tackle an overview about the law of reflection. The law of reflection was first discovered by Ibn al-Haytham in about 300 BCE. The law of reflection states that the angle of reflection is equal to the angle of incidence. Whenever you look into a mirror or squint at sunlight glinting off a lake, you are seeing a reflection. When you look at the text in a book, you are actually seeing the light that is reflected from it. Large telescopes use reflections to form images of stars and other astronomical objects. In fact, the only way we can see an object that does not itself emit light is if that object reflects light. The law of reflection states that the angle of reflection equals the angle of incidence, or theta r is equal to theta I. The angles are measured relative to the perpendicular to the surface at the point where the ray strikes the surface.
Good day, I am Miracle Ortiz and today we'll be tackling about the Malus Law. Malus Law helps us study of light, intensity relation of the polarizer-analyzer. It plays a vital role in the understanding the polarization properties of light. The Malus Law history. The law was named after French engineer, physicist, and mathematician Etienne Louis Malus. In the year 1808, he discovered that natural light could be polarized when it was reflected by a glass surface. Malus' law is stated when the intensity of a plane polarized light that passes through an analyzer varies as the square of the cosine of the angle between the plane of the polarizer and the transmission axis of the analyzer. A polarizer is an optical filter that lets light waves of a specific polarization pass through while blocking light waves of other polarizations. So what is a polarizer? A polarizer is an optical filter that lets light waves of a specific polarization pass through while blocking light waves of other polarizations. Analyzer is a device used to check if the light is plane polarized or not. It can be considered as a second polarizer.
Now, these are the facts. The law of Malus states that the intensity of plane polarized light that passes through an analyzer varies as the square of the cosine of the angle between the plane of the polarizer and the transmission axis of the analyzer. So, what is the difference between unpolarized light and polarized light? Unpolarized light has the orientation of the electric field vectors in all possible directions, whereas polarized light has the electric field oriented in a single direction. For the formula of Malus' law, I is equals to I max multiplied to cosine squared to beta, where I max is the original intensity and beta is the angle between the direction of polarization and the axis of the filter. The formula states that the intensity of the light transmitted by the analyzer is directly proportional to the square of the cosine of angle between the transmission axis of the analyzer and the polarizer.
Hello, my name is Tyron Rushabisa, and today I will be talking about the formula for Snell's law. The formula for Snell's law is as follows. N1 multiplied by sin theta 1 is equals to N2 multiplied by sin theta 2. The N1 and N2 represents the indices of refraction for the medium, and theta 1 and theta 2 represents the angle of the rays relative to the medium. So, for an example, we will have a ray of light go through from air to water. The index of refraction of air is 1.0003 and the angle that it will enter in is 10 degrees. The index of refraction of water is 1.333 and we will be looking for the angle of which it comes out. First, we will substitute the values. Then after substituting the values, you will isolate the value we are looking for, which is theta 2. We will do this by dividing both sides by 1.333. after this, you will get 0.1302 and sine theta 2. In order to remove the sign, you will use the inverse sign. The inverse sign of sine theta 2 is simply the angle theta 2. And the inverse sine of 0.1302 is 7.48 degrees. And that is all. Thank you for listening.
The amount that a light ray changes its direction depends both on the incident angle and the amount that the speed changes. Looking at the fish tank as shown, we can see the same fish in two different locations because light changes direction when it passes from water to air. In this case, the light can reach the observer by two different paths, and so the fish seems to many optical phenomena. Refraction, the changing of light rays direction when it passes through variation in matter.
Total internal reflection. Complete reflection of a ray light within a medium such as water or glass from the surrounding surface back to the medium. The phenomenon occurs the angle or incidence is greater than certain limit angle called the critical angle.
The Brewster angle, also known as polarization angle, is the angle of incident, at which the light polarizes parallel to the plane of incident, which is completely transmitted through a medium without any reflection. This special type of angle of incident is named after the Scottish physicist known as Sir David Brewster.
As you can see in the figure that is shown on the screen, the refraction light is emitted perpendicular to the direction of the dipole moment. Thus, if the angle of reflection theta 1 and theta 2 is the angle of refraction, no light is reflected. An illustration of the polarization of light, that is, equal to the alignment of the dipole where the theta 2 is the angle of refraction, no light is reflected. An example would be shown on the next slide. The action of Polaroid sunglass. Light reflected from surface like flat road or smooth water is generally horizontally polarized. This horizontally polarized light is blocked by the vertically oriented polarizers in the lenses.
Now, let's talk about dispersion or dispersion of light. When the white light is passed through a glass of prism, it splits into spectrum of colors. So basically, it is the process of splitting up of white lights on reflection into many colors. When the white light falls at a certain angle on a glass prism, it splits into 7 component colors, which are red, orange, yellow, green, blue, indigo, and violet, or also known as rojo-beef. This band of colors when light is split is called a spectrum. Rainbow is an example. So example of this is rainbow. When the rainbow is one of its example. When the sunlight passes through the raindrops at a certain angle, it splits and forms a rainbow. So that is one example of a dispersion of light.